Hi, my dear student friends. Welcome to AS Engineering College YouTube live session, which is for revision series of university examination preparations. Okay. So today our topic is vector differential equations, vector differentiation, vector differentiation. Okay. So on this, so the list of contents: introduction of vector differentiation, definition of gradient and its properties and problems, definition of divergent properties and its problems, and definition of curl properties and its problems, and vector identities. These are the topics we are going to discuss under vector differentiation. Okay. So first, basic definitions let us try to know, because in further we are going to have scalar point function, vector point function used to mention. So what is the scalar point function? What is vector function? Vector point function, let us try to know. So scalar point function, a scalar point function is defined as a function which assigns a real number to every point of a part of the region of the space. Okay. So if to every point P of a region of 3D space there is assigned a real number, a function or if a scalar point function is at which means at every point in this 3D space the function is assigned with a real number. So that is by m is equals to phi of x comma. Phi is a function. The value of phi at point P I am just giving by m. Okay. So then phi is called a scalar point function. Vector point function. Vector point function is a function which assigns a vector to each point of some region of space. Okay. So if to each point P of a region of space they are assigned a vector to the point P. Okay, they are assigned a vector, a bar. Okay, to each point, a vector point function is a function assigns a vector to each point. So that is dependent by a bar of x comma y z equals to f1 of x comma y comma z I bar plus f2 of x comma y comma z j bar plus f3 of x comma y comma z into k bar. So then a bar of x comma y comma z is called a vector point function. Okay, at every point, at each point in the space, we are going to assign a vector. So in the scalar, we are going to assign a real number. That is the difference between scalar point function and vector point function. Scalar point function represents a space, and vector point function represents a 3D, means it's a plane. Next, introduction. Vector calculus. Of course, vector differentiation is a part of vector calculus or vector analysis, we used to say, is concerned with the differentiation, integration of vector fields partially in three-dimensional Euclidean space. Okay, in three-dimensional space, we are going to discuss vector calculus. Vector calculus is vector analysis over a differentiation and integration in three-dimensional space. Okay, the term vector calculus is sometimes used as broader subject of multivariable calculus. Okay, the vector calculus is sometimes used to call because it's a three-dimensional space application, no? So multivariable calculus, which involves vector calculus such as well as partial differentiation in 3D space and multi-integration. Okay, partial differentiation and multi-integration is involved. Next, vector calculus plays an important role in differential geometry and in the study of partial differential equations. So these are the introduction part of vector differentiation is vector calculus. Next, definition of gradient. See, very important definition of gradient you may expect for short answers. For short answers type, you may expect definition of gradient. Okay, so this is for short answers. For 2 marks, you may expect definition of gradient. So gradient is a vector differential operator on a scalar point function. What is scalar point function? I have already said. Okay. So gradient of a function is defined to be vector field, and generally the gradient of a function can be found by applying the vector operator to the scalar point function. This kind of vector fields known as gradient vector fields, and it is defined by grad. Gradient means grad of scalar point function, that is usually symbolically we represent by del phi of x comma y comma z, which is equals to I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. Okay, means we are applying differential operator in a scalar point function. So this is what you use to write I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou. This is a differential operator on a scalar point function. Note here, the gradient of a scalar point function is normal to the surface. So this is a surface in a 3D space. This is a surface function. For this, if I apply a gradient, that gradient function becomes, that vector function becomes normal to the surface. Next, applications of gradient of vector point function. So it is a multivariable calculus that we have already known. Multivariable calculus means 3-dimensional. We used to discuss on 3-dimensional space. In 3-dimensional space, we discuss 3-dimension means multi-differentiation, means partial differentiation, multi-integration we operate. And another one is flow method of treating satellite image. The flow of satellite image we can use of gradient applications. Okay, to treat the flow method for treating satellite image, we use gradient vector applications. Okay, so behind treating means flow method of treating satellite image, we apply, means behind that the applications are gradient vector applications. Now let us go for solving a problems. Okay, so now phi of x comma y z is equal to phi of x y z equals to x y z. Then find del phi, means grad phi. Del phi is nothing but grad phi. So now, so phi of x comma y comma z equals to x y z. On this gradient, means del phi we are applying. So I already said del is nothing but I bar dou by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. Okay, where phi means, as in the place of phi of x comma y comma z, I am simply writing phi. Now, which is equals to I bar into phi, differentiation with respect to x is going to be yz, plus j bar into phi with respect to y going to be xz, plus k bar into phi with respect to z is going to be xy. So this is del phi. Del phi or gradient of phi. Del phi or gradient of phi. Next, find del of x square plus y square z, and second one is del of x square minus yz plus z square. Now I am just going to evaluate del is nothing but a gradient. Del of x square plus y square z is equals to I bar into dou by dou x of x square plus y square z plus j bar into dou by dou y of x square plus y square z plus k bar into dou by dou z of x square plus y square z. Okay, so which is equals to I bar into with respect to x. So here x square only we have, x square differentiation is 2x plus j into and the rest of the differentiations are going to be 0, as there are y square z are independent of x sums treated will be treated as constant, so whose differentiation is 0. Only x square differentiation to x I wrote. J bar into dou by dou y of x square is 0, dou by dou y of y square is 2y followed by z, as the y square is with z is under multiplication with y square, so y square differentiation is 2y and followed by z, plus k bar into dou by dou z of x square plus y square z. So dou by dou z of x square is going to be 0, which is independent of z term. So y square z we have, dou by dou z of y square z is going to be y square. So therefore del of x square plus y square z is equals to 2xi bar plus 2yz j bar plus y square k bar. So this is for the first question. Second one, del of x square minus yz plus z square. Del of x square minus yz plus z square. Okay. Similarly, you write. So which is equals to I bar into dou by dou x of x square minus yz plus z square plus j bar into dou by dou y of x square minus yz plus z square plus k bar into dou by dou z of x square minus yz plus z square. Okay. So now dou by dou x of this x square differentiation is 2x, and the rest of the two terms are going to be 0, as these two terms are independent of x. So whose differentiation is 0. So dou by dou x of x square is 2x into I bar 2xi bar plus, and dou by dou y of x square differentiation 0 and yz differentiation is minus z, minus y differentiation 1 and z will be as it is, as y and z are under differentiation, under multiplication, whose differentiation will be minus z k bar, minus z j bar. Last one z square, that is treated as constant, which is independent of y term. So dou by dou y of z square is going to be 0, plus k bar into dou by dou z of this. So in this we have two terms with a z, with two terms with z. So differentiation of minus yz is minus y, z term is going to be 1, and z square differentiation is 2z. Okay. So this is del of x square minus yz plus z square. Okay. So these are like 2 marks short answer type questions which are asked in previously. So I am explaining here. Next one, find the normal vector, unit normal vector to the surface. So I already said in the introduction part, in the definition of gradient, normal vector is nothing but if I apply a gradient to the scalar point function, then the gradient of a scalar point function becomes a normal vector to the scalar point function, right? So now this is a surface, means this is scalar point function or a surface function. So now I am taking a surface function by phi of x, y, z is equals to x cube plus y cube plus 3xyz minus 3 is equal to 0. I am taking a surface function, means scalar point function. So for this I will apply gradient. Okay, for this I will apply gradient. Now del phi equals to I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. Okay. So which is equals to I bar into dou phi by dou x. This is phi. So now dou phi by dou x. Dou phi by dou x. With respect to x, differentiation of this with respect to x. X cube differentiation 3x square. X cube differentiation 3x square plus y cube differentiation 0. 3xyz differentiation is 3yz plus 3yz plus j bar into, so dou phi by dou y. So with respect to y, x cube differentiation 0, y cube differentiation becomes 3y square plus and 3xz with respect to y, so y term is going to y is differentiation is 1, so 3xz plus k bar into dou phi by dou z with respect to z. So this becomes 0, which are these two are independent of z terms, so whose differentiation is 0, but 3xyz is a dependent on z term, so z differentiation is going to be 1, so left by 3xy. Okay, so now del phi at which point 1 comma 2 comma minus 1, 1 comma 2 comma minus 1 means in the place of x you put 1, in the place of y you substitute 2, in the place of z you put minus 1. If I do that, what do you get? 3 into 1 square is going to be 3 only, plus 3 into 2 into minus 1. So 3 into 2 is 6, 6 into minus 1 is minus 6, plus 3. Minus 6 plus 3 is minus 3. Minus 6 plus 3 is minus 3 into I bar plus j bar. J into 3y square plus 3xz. Substitute x y by 2, 2 square, that is going to be 12, plus 3 into 1 into minus 1 is going to be minus 3. 12 minus 3 is 9j bar. Isn't it? When I put x is equal to y is equal to 2, 2 square means 4, 4 into 3 is 12, plus 3 into 1 into minus 1, it is going to be minus 3. 12 minus 3 is 9. I am directly evaluating that. Plus substitute 3 into x into means 3 into x into y, 3 into 1 into 2 is going to be 6k bar. 6k bar is normal vector to surface phi, to the surface function phi at the point 1, 2, minus 1. At this point 1, 2, minus 1, this becomes normal vector. But also asking unit normal vector. So unit normal vector equals to, means normal vector, what you got? Normal vector y equals to 3 minus 3i bar plus 9j bar plus 6k bar. Unit normal vector. Now I am evaluating this, we can represent by n bar. We can also represent this by n bar. So now unit normal vector. So we can also write normal vector of phi means del phi, we can also write. So del phi is equal to that. Unit normal vector equals to del phi by mod del phi. Del phi by mod del phi. So which is equals to minus 3i bar plus 9j bar plus 6k bar by modulus of del phi means root of minus 3 whole square plus 9 square plus 6 square. So unit normal vector means n bar by n bar by modulus of n bar used to represented by E cap or E bar. So which is equals to, that implies E bar equals to, or unit normal vector equals to, minus 3i bar plus 9j bar plus 6k bar by minus 3 whole square is 9. 9 plus 9 square 81. 81 plus 9 is 90 plus 36. 126. 90 plus 36 is 126. Root of 126. So root of 126 means what you can write? 126 means what how you write? 49s are 126 na? Okay, 49s are 126. So 9 square root is 3. So we write this as 3 root 14. 3 root 14 we can write. So when I take 3 common from the numerator, it becomes minus I bar plus 9j bar plus 2k bar by root 14. This is E bar. This is the unit normal vector of a given surface. This is a unit normal vector for the given surface, right? So I evaluated normal vector, that is this one, I evaluated, and unit normal vector I evaluated. Next, directional derivative. So on this topic, mostly the sums are asking on directional derivative, and that too it's very important topic, and also they are asking definition of directional derivative, and also they are asking directional derivative definition. So please once have this. The directional derivative is the rate at which any function changes at any point in a fixed direction. Any function changes at any point in fixed direction means the changing the position means change of a function. The function changes, its nature, maybe that structure maybe changes at some fixed point, at a point in a fixed direction. So it is a vector form of a derivative. So directional derivative is a vector form derivative. It's a derivative operator only, differential operator only. But the character is the instantaneous rate of modification of the function. So it defines characteristics of the function, instantaneous characteristics of the function. Instantaneous characteristics of the function it defines. And it generalizes the view of a partial derivative. Okay, and it is defined as the directional derivative of a scalar point function phi at any given point is E bar dot gradient of phi. E bar dot gradient of phi or E bar dot del phi used to. That is the formula for evaluating gradient. Okay, so here where is E bar? What is E bar here? Unit normal vector. That is n bar by modulus of n bar. Where n bar is normal vector, we already discussed E bar and n bar, right? So this is gradient directional derivative, directional derivative. So applications. So in the design of animation characters and the background elements, directional derivative applications are there. Behind animation design of animation and the background elements, design of background elements and all, it's application of directional derivative only. Okay, behind these operations there is a directional derivative applications. And electromagnetic theory, in fluid dynamics and in elasticity and plane of old mechanics, in these fields also a lot of directional derivative applications involved, right? So these are the applications you can have from directional derivative. Next, I am going to discuss the problem here. Find the directional derivative of that function at this point in the direction of the surface 3xy square plus z is equal to z at the point 0, 1, 1, 1. Means So what is the directional derivative? This function. What is the derivative of that function? What is the change of that function at this point? At this point, in the direction of this vector, in the direction of this vector corresponding to the surface. With respect to the surface or in the direction of the surface, how the rate of change of a function happens, how the rate of change, how the characteristics of the function we evaluate. That is going to be discussed here. Okay. Now, so I am going to evaluate first what is actually directional derivative. Directional derivative used to say simply dd. Directional derivative formula is E bar dot del phi. Okay. Now first find out here phi equals to, I am taking phi is equals to x y z square plus xy xz, x y z square plus xz. Now I am going to evaluate del phi. Del phi, so means I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. So which is equals to dou phi by dou x. Here x differentiation 1, yz square only left, plus xz differentiation with respect to x is going to be z into I bar, plus dou phi by dou y with respect to y is going to be j bar into xz square, plus k bar into with respect to z 2xyz plus x. This is del phi. This is del phi. But we have to evaluate directional derivative at this point. At this point means you have to evaluate del phi at the point 1, 1, 1, 1. And E bar we have to evaluate at the point 0, 1, 1, 1. Unit normal vector you have to evaluate at 0, 1, 1, 1. And del phi we have to evaluate at 1, 1, 1. Okay. So then del phi at 1, 1, 1 is equals to, if I keep x is equal to 1, y is equal to 1 and z equals to 1, it is going to be 2 I bar plus j bar, because x is 1, z is 1, whose product is going to be 1. 1 into j bar is j bar only, plus 2 plus 1, 3 k bar. So 2 I bar plus j bar plus 3 k bar. 2 I bar plus j bar plus 3 k bar. Okay. So this is the gradient of a function I evaluated. Now I have to evaluate E bar. So E bar means unit normal vector to the surface. Okay. In the direction of this vector we are going to evaluate directional derivative. Okay. Now E bar equals to n bar by mod n bar, where n bar equals to del of this function 3xy square plus z minus 3xy square plus y minus z for this function. So 3x y square plus y minus z. Okay, means gradient of this function. N bar is nothing but normal vector. Normal vector is evaluated by applying gradient to the surface function. So this is a surface function, I am applying gradient. So you know that what is gradient? Del means I bar into differential operator, dou by dou x plus j bar into dou by dou y plus k bar into dou by dou z, k bar into dou by dou z, of 3xy square plus y minus z. Okay. So which is equals to? So I bar into dou by dou x of this 3y square right, I bar into 3y square plus j bar into dou by dou y of that 3xy square differentiation is 6xy plus 1. 6xy plus 1 plus k bar into dou by dou z of this that is going to be minus 1. Okay, so which is equals, now I am going to evaluate n bar at the point. What is the point he is provided? 0, 1, 1, 1. So at 0, 1, 1, 1 is equals to, when I keep x is equal to 0, y is equal to 1 and z is equal to 1. So it is going to be 3 I bar. When I put y by 1, when I put y by 1, so 3y square is going to be 3 into I bar plus 6 into x 0 na. So this term is going to be 0, only 1 j bar, means j bar will be left, and minus k bar. Okay, so then E bar equals to n bar by modulus of n bar. At this point I am going to evaluate E bar. So which is equals to 3 I bar plus j bar minus k bar by root of 9 plus 1 plus 1 is 11. This is E bar. Okay. Now directional derivative is E bar dot del phi. So E bar here we have and del phi we have. So therefore directional derivative equals to E bar is 3I bar plus j bar minus k bar by root 11. 3I bar plus j bar minus k bar by root 11 dot n bar is 2I bar plus j bar plus 3k bar. Okay, unit normal vector into gradient of a function. So now you multiply, what do you get? So dot product is happened between the same component vectors. 3I bar dot 2I bar is 6 plus j bar dot plus j bar is plus 1 minus k bar dot plus 3k bar is minus 3 by root 11. 6 minus 1 is 7 minus 3 is 4, 4 by root 11. 4 by root 11. So this is directional derivative of a given function. It's a measure of. Next, find the directional derivative of the function at the point. At this point, he is asking us directional derivative of this function in the direction of the line PQ. Okay, directional derivative of the function at this point in the direction of PQ. So directional derivative formula again, directional derivative of f is equals to E bar dot del f. Okay, so del f is at the point 1, 2, 3 and E bar is evaluated along the line PQ. E bar is evaluated along the line PQ. in the direction of line PQ, E bar is evaluated, means in the direction of PQ only we are going to evaluate direction derivative. Now first try to evaluate del F first. Del F equals to I bar into dou by dou x, dou F by dou x plus J bar into dou F by dou y plus K bar into dou F by dou z. So which is equals to I bar into dou F by dou x with respect to x, it is going to be 2x plus J bar into dou F by dou y means minus 2y plus K bar into dou F by dou z is 4z. Okay. Now I am going to evaluate del F at the point 1, 2, 3. At the point 1, 2, 3. X by 1, y by 2 and z by 3. So if I put x by 1, it is going to be 2I bar plus if I keep y by 2, it is going to be minus 4 into j bar minus 4j bar. Minus 4j bar, this is minus 4 j bar and keep z by 3. 4 into 3 is 12. 12 into k bar plus 12 k bar. This is del F. Okay, del F I evaluated at the point 1, 2, 3. Now I have to evaluate in the direction vector. In which direction we are going to evaluate? In the line, along the line PQ, na? So along the line PQ I have to evaluate unit normal vector. So that is E bar equals to n bar by mod n bar. N bar is normal vector. Normal vector is evaluated along the line PQ. Along the line PQ. Okay. So here let us try to find the vector PQ bar. PQ bar vector I am going to define here. So PQ bar, vector PQ bar is equals to OP bar minus OQ bar. OP bar minus OQ bar, that is a PQ bar formula. The vector PQ bar evaluated by OP bar minus OQ bar. That is OQ bar minus OP bar. So that is just you take the difference of these two, 5 minus 1, 4I bar, 0 minus 2, minus 2j bar, 4 minus 3, 1k bar. Okay. So it's a PQ bar, how I am evaluating now? Just difference of the points P to Q, PQ to P to Q. So from the point P to the point Q, from the point Q to point P. So 5 minus 1 is 4, 0 minus 2 is minus 2, 4 minus 3 is 1. So that is 4I bar minus 2j bar plus 4 minus 3 k bar. Okay. So here I will tell this means P equals to 1, 2, 3 and Q equals to 5, 0, 4. I will evaluate position vector OP bar. So OP bar equals to 1I bar plus 2j bar plus 3k bar. Okay. This is the position vector of the point P. And with respect to the point Q, the position vector is going to be evaluated by OQ bar, that is 5I bar plus 0j bar plus 4k bar. Now you evaluate PQ bar equals to OQ bar minus OP bar. OQ bar minus OP bar. So this is the way of finding the vector OP, the vector PQ. Okay. Which is equals to 4I bar minus 2j bar plus k bar. Now I am going to evaluate normal vector to the vector PQ, equals to 4I bar minus 2J bar plus K bar. N bar is evaluated along the vector PQ bar. So then whose normal vector E bar equals to 4I bar minus 2J bar plus K bar by root of 4 square, 16 plus 4 plus 1. So minus 2 whole square is 4 and 1 square is 1. I evaluated normal vector to the normal vector along the vector PQ. So the PQ bar becomes a N bar. So then E bar equals to 4I bar minus 2J bar plus K bar by root of 21. This is E bar. Okay, directional derivative is evaluated along the line PQ bar. So the vector PQ bar itself a N bar. Okay, the line PQ bar means the vector PQ bar itself a N bar. So from N bar I am just evaluated E bar. So now directional derivative of F equals to E bar dot del F. E bar dot del F. E bar is evaluated along the line PQ bar or using the PQ bar into del F. So what is E bar here? So here no need to mention that. PQ bar not required. Just I am saying E bar equals to 4I bar minus 2J bar plus K bar by root of 21. Dot del F. What is del F we got? 2I bar minus 4J bar plus 12K bar. 2I bar minus 4J bar plus 12K bar. Now apply the dot product. So 4I dot 2J is 8 minus 2J minus 4J is plus 8 again. Next K bar dot 12K bar is going to be plus 12 by root of 21. Okay na? So 4I bar dot 2I bar equals to 8. Next minus 2J bar dot minus 4J bar is going to be plus 8. Next plus 1K bar dot 12K bar is going to be 12 by root of 21. So which is equals to 16 plus 12 is 28 by root of 21. So this is directional derivative of F at the point 1, 2, 3. At the point 1, 2, 3. Okay. If the points is provided, instead of giving surface instead of surface function, he provided PQ. He provided the line PQ. Along the line PQ, you evaluate vector function. So that vector function becomes a N bar. Okay. So from that N bar, you evaluate your normal vector and proceed for the finding directional derivative. Next, here directional derivative, what is the significance here? The greatest value of directional derivative is modulus of del phi. Okay, directional derivative means in which direction of vector function you are going to find directional derivative. That direction function gradient you take and means modulus of n bar. Normal vector, modulus of n bar, yes. Okay, del phi is gradient of surface function. right? So now let us see one problem. In what direction from the point minus 1, 1, 2 is the direction derivative phi is maximum? In what direction? This surface function is maximum at the point minus 1, 1, 2. In which direction of the vector function? Means you have to find del phi. Directional function we have to find. In which direction means del phi you have to find at the point. So now I am going to apply directional derivative. Directional derivative of phi means del phi I am finding. Directional derivative means del phi. In the direction of this phi we are going to evaluate the directional derivative. Del phi equals to I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z, which is equals to I bar into dou by dou x of x y square z cube plus j bar into dou by dou y of x y square z cube plus k bar into dou by dou z of x y square z cube. So which is equals to I bar into dou phi by dou x, it becomes y square z cube plus j bar into dou by dou y of x y square z cube becomes 2xy z cube, 2xy z cube plus k bar into dou by dou z of x y square z cube becomes 3xy square z square. Z cube differentiation is 3z square. So this is del phi. So in the direction of this vector, in what direction they are asking, in the direction of this vector the directional derivative is defined. So we are at one point, at minus 1 comma 1 comma 2, sorry, at the point, so now in which direction means del phi at the point minus 1 comma 1 comma 2. Substitute x by minus 1, y by 1, z by 2. So 1, 2, 1 square is 1, 2 cube is 8, 8 into 1 is 8, 8 I bar. And 2xyz cube, 2 into minus 1, minus 2 into 1, minus 2 into 8, z2 cube is 8, minus 2 into 8 is going to be minus 16 j bar. Next, plus k bar into 3 into minus 1, minus 3 into 1, minus 3 into 4, minus 12 k bar. Okay, so in the direction of, in what direction means? In the direction of del phi at 1 2 minus 1 comma 1 comma 2, that is 8 I bar minus 16 j bar minus 12 k bar, 8 I bar minus 16 j bar minus 12 k bar. In the direction of del phi, the directional derivative is maximum. The directional derivative of phi, directional derivative of phi is maximum equals to modulus of del phi, the point minus 1 comma 1 comma 2. that is 8 I bar minus 16 j bar minus 12 k bar by okay, modulus of del phi means modulus of this, which is equals to 8 square plus 16 square plus 122 square under root. So 64 plus 16 square is 326 plus 12 square is 144. So this is going to be 390 na? 390 plus 100 is 490 plus 490 plus 44 is going to be 534 na? So which is equals to 534. So this is the maximum value in the direction of this vector. In the direction of this vector, the maximum value attained is root of 134. Right? This is the maximum value. Next, the angles between the normals to the surfaces. So we have two surfaces, phi 1 and phi 2. We have two surfaces, phi 1 and phi 2, whose normals is del phi 1. Whose normals are del phi 1 and del phi 2. So phi 1, for the surface phi 1, normal is del phi 1. For the surface phi 2, normal is del phi 2. The angle between these two normals means this we represent by n1, this we represent by n2. Okay, the angle between these two normals is, formula is cos theta equals to n1 bar dot n2 bar by modulus of n1 bar into modulus of n2. Right. Now let us see one problem on this. So find the angle between the normals to the surface at the point 111 and 241. So for surface function is given. Surface function phi of x comma y comma z is equals to x square minus yz is equal to 0. So from this surface function I am taking by phi of x comma yz equals to x square minus yz. Okay, so at the point 1 1, del phi, first you find out del phi. So del phi equals to I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. Right? So which is equals to I bar into dou phi by dou x. Phi is x square minus yz. So x square minus yz with respect to x is 2x. And dou phi by dou y with respect to y is going to be minus z plus j bar into minus z plus k bar into with respect to z minus y. So this is del phi. This is the normal vector to this surface. But corresponding to the points, you will get two normals to the surface. Two normals you will get. You will get two normals to the given function at respective points. Now I am evaluating n1 that is del phi at the point 111 is equals to, means n1 means first normal vector to the point to the given function, means the first normal vector to the given function at the point 111 is n1 equals to, put x is equal to 1, y is equal to 1, z is equal to 1. In this you will get 2I bar minus j bar minus k bar. Minus k bar. Okay. Next, similarly n2. N2 means del phi at the point 241. is equals to, when I put a x is equal to 2, 4I bar and z is equals to minus 1, z is equal to 1 minus j bar and y is equal to 4, that is minus 4k bar. Okay, so we evaluated n1 and we evaluated n2. Two normals we evaluated to the given surface. For the given surface, we got two normals at respective points. Now, so cos theta formula, cos theta equals to n1 bar dot n2 bar by modulus of n1 into modulus of n2, which is equals to n1 bar 2I bar minus j bar minus k bar, 2I bar minus j bar minus k bar dot 4I bar minus j bar minus 4k bar, 4I bar minus j bar minus 4k bar by modulus of n1 bar means root of 2 square plus 1 square plus 1 square, that is root 6, into modulus of n2 bar is 4 square plus 1 square plus 1 square plus 4 square. So which is equals to 2I bar dot 4I bar is 8 minus into minus plus minus j bar dot minus j bar is plus 1 minus k bar dot minus 4k bar is 4 plus 4 by root 6 into root of 16 plus 16 is 32 plus 1 is root 33, root of 33. So 8 plus 1, 9 plus 4, 13, 13 by root of 6, 198, 198. Even if I bring 9 common, so means 9 twos, so 13 by 3 root of 22, 22 9s 198, so 9 root will be 3, so 3 into root of 22. So this is angle between, therefore the angle between the two normals theta equals to cos inverse of 13 by 3 root 22. Theta equals to cos inverse of 13 by 3 root 22. This is the way of finding angle between the two normals. Right. In similar way, right, find the values of A and B so that the surfaces ax square minus byz is equals to a plus 2 into x and 4x square y plus z cube is equal to 4 may intersect orthogonally at the point 1 minus 1, 2. So we have two surfaces. This is one surface function and this is another surface function. For these two surface functions, you will get a normals. Those two normals are orthogonal to each other. The normals of these two functions are orthogonal to each other, means they are intersecting orthogonally, perpendicularly. So then what is the values of A? What is the value of E? What is the value of A and B? What is the value of A and B? Asking. Right? So now, here, angle between the two normals, angles between the two normals is cos theta equals to n1 minus n1 dot n2, n1 dot n2, n1 bar dot n2 bar by modulus of n1 bar into modulus of n2 bar. When orthogonality exists, orthogonality means angle is 90 degrees, perpendicular means 90 degrees. So cos pi by 2, cos pi by 2 is equals to n1 bar dot n2 bar by modulus of n1 bar into modulus of n2 bar. This implies n1 bar dot n2 bar is equal to 0 since cos theta by 2 value is 0. When if angle between the two normals is 90 degrees or the normals are intersecting at orthogonally, then the angle, then the relation, the condition is n1 bar dot n2 bar is equal to 0. So this I will use, this condition I will use to evaluate A and B, right? Now I am going to evaluate first n1 bar and n2 bar. Now n1 bar, so here I will take first phi 1, first now surface function, that is ax square minus 5 minus byz, ax square minus byz minus of a plus 2 into x. This is first surface function is equal to 0, is there, but I am not taking for defining normal vectors. Is equal to 0 is there, if you want you can take. Okay. Now second surface function I am taking by 4x square y plus z cube minus 4. 4x square y plus z cube minus 4. These are the two surface functions. These are the two surface functions. If you want, you can take is equal to 0, is equal to 0. Okay. Now I am going to define normals to the surface function 1, surface function 2 at the point, at the given point. So now I am evaluating n1. n1 means del phi 1. Del phi 1 means I bar dou phi 1 by dou x, j bar dou phi 1 by dou y plus k bar dou phi 1 by dou z. Okay. Dou phi 1 by dou x, this is phi 1 with respect to x, 2ax, you will get I bar into 2ax, and this is 0, this is independent of x term, and this is dependent of x term, so whose differentiation is going to be minus of a plus 2, means minus a minus 2. X differentiation 1, so minus of a plus 2 is left, means minus a minus 2 plus j bar. So dou phi 1 by dou y with respect to y, if I do, you will get minus bz. You will get minus bz. That is the only y term we have. So whose differentiation minus bz. And plus k bar dou phi 1 by dou z. Dou phi 1 by dou z means with respect to z. Here only z term is minus byz term. So in this only z is there. So whose differentiation is going to be minus by. Minus by. So this is del phi 1. Now del phi 1 at the point, what is the point provided? 1 minus 1 2. 1 minus 1 2. 1 minus 1 2. If I put x by 1, y by minus 1 and z by 2. So x by 1 means 2a minus a. If I put x by 1, 2a into x is 2a, minus a is a, minus 2, a minus 2, plus j bar into b, minus b into z, z is 2, so minus 2b, minus 2b, plus k bar, so y is minus 1, minus b into minus 1b, so which is equals to n1 bar equals to a minus 2i bar minus 2b j bar plus k bar, k v bar, v k bar or b k bar, a minus 2 I bar minus 2b j bar plus b k bar. This is n1 bar, right? So now n2 bar I will evaluate. N2 bar equals to del phi 1, del phi 2, del phi 2 I bar dou phi 2 by dou x plus j bar dou phi 2 by dou y plus k bar dou phi 2 by dou z. So which is equals to dou phi 2 by dou x, x square differentiation 2x, 2x into 4y 8xy, I bar into 8xy plus j bar into dou phi 2 by dou y differentiation 1 4x square, j bar into 4x square plus k bar into dou phi 2 by dou z with respect to z 3z square. Now I am going to evaluate n2 at the point. Now n2 equals to del phi 2 at the point 1 minus 1 2, at the point 1 minus 1 2. Okay, now I substitute 1 minus 1 2. If I put 1 minus 1, 1 minus 1 means minus 1 into 8, minus 8 I bar plus 4 into 1 square, x by 1 na, 4 into 1 square, that is 4, plus 4 j bar. Next 3z square, where z is 2, z square is 2 square is 4, 4 into 3, 12 k bar, plus 12 k bar. So n2 is 12 k, n2 is 12 k bar, n2 bar equals to minus 8 I bar plus 4 j bar plus 12 k bar. Okay, so here normal vectors n1 bar and n2 bar are orthogonal to each other. That is n1 bar dot n2 bar is equals to 0. Now dot product between n1 bar, this is n1 bar dot n2 bar. Now n1 bar, a minus 2 I bar dot minus 8 I bar means a minus 2 into minus 8. Next minus 2bj dot plus 4j means minus 8b, minus 2b plus 4 means minus 8b. Next plus b k bar dot 12 k bar means plus 12b is equal to 0. So when I multiply minus 8a plus 16 minus 8b plus 12b is plus 4b is equals to 0. Okay, now if I divide by 4, minus 2a plus 4 plus b is equal to 0. Okay, so from this b equals to what we can write 2a minus 4. This is the relation we are getting for b and a. So here you have two unknown constants, but we had only one equation we got. Still you need one more equation to find a and b. With a single equation you cannot find two unknown constants. To find two unknown constants you require at least two equations. So another equation you need to find. Well, how we find another equation means, see, these two surfaces means this is surface 1 and this is surface 2 are intersecting at the point orthogonally. So this is surface 1, phi 1 and this is surface 2. So these two intersecting orthogonally. means these two at this point that is 1 minus 1 2 means these surfaces are passing through the point 1 minus 1 2 na, means this point satisfies this equation, no? Okay, as the surfaces are, two surfaces are intersecting at this point orthogonally, therefore this equation has to satisfy the point. So that I will take here. So now ax square minus byz is equal to a plus 2 into x equals to a plus 2 into x is passes through the point what is the point here? 1 minus 1 2 1 minus 1 2. So then this equation has to satisfy by the point 1 minus 1 2. So therefore a into 1 square minus b into y is minus 1 and z is 2 is equals to a plus 2 into 1. So a plus b plus 2b, a plus 2b minus into minus plus 2 into b is 2b is equals to a plus 2. Okay, here on either side a term we have that will be get cancelled, then from this b is going to be 1, b is 1. So here b is equal to 1 na? So when b is equal to 1, then b equals to 2a minus 4 we have, b equals to 2a minus we have, b equals to 2a minus 4. From this a equals to, what do you get? 5 by 2, a is equals to 5 by 2. If I put b is equal to 1, 1 equals to 2a minus 4, bring minus 4 this side, 1 plus 4 is going to be 5, 2a is equal to 5, then a is equal to 5 by 2. So therefore the b value, a value is 5 by 2 and b value is 1. Okay, this is the way of finding values a and b when the normals of the two surfaces are intersect orthogonally at the point 1 minus 1 2. So like this you need to, this type of problems very frequently asking in university examinations. You please focus on this type of problems. Next, divergence of a vector. Divergence explains how the field behaves towards away from the point. Diverge means how it is moving away from the source. Divergence is a differential operator, of course. Divergence is also a differential operator. The divergence of vector fields a scalar field. If I apply a divergence to a scalar point, vector field, it is going to be scalar. Divergence of a vector field is going to be scalar field. We are going to apply divergent on vector point function. It gives a scalar point function. Whereas gradient, we apply on a scalar point function, we get a vector. And the divergence is generally denoted by div, used to, how we write gradient means grad or del. Similarly, divergence used to represented by grad or del dot, used to represent by del dot. So the divergence of vector field can be calculated by taking the scalar product of the vector differential operator to the vector field. Vector differential operator and scalar product means dot product to the vector field. So gives what? Scalar point function. See, this is direct formula. Del dot f bar equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by, here f3, dou f3 by dou z. Where f1 means f bar means defined by f1 I bar plus f2 j bar plus f3 k bar. See, I bar differential, j bar and k bar. So directly, if the function is given in this form, means if function, vector point function given like this, whose direction derivative, whose divergent of vector function is going to be right like in this way. This is the formula you use for finding direction, means divergence of vector function. Divergence of vector function, you use that formula. Applications. A moving fluid or gas has a velocity, speed and direction at each point, can be represented by a vector. So the velocity of the fluid or gas forms a vector field. Okay, a fluid or a gas, it moves, means it moves in some direction. It has some velocity or speed. Okay, so that represents a vector field. That represents a vector field. Okay, if a gas is heated, it will expand. It will get expand, and it can tell you how fast or maximum and in what direction the fluid gas is moving. Okay, this directional means divergence of vector field help us to evaluate in which direction it moves, at what fast, how fast it is moving, in which direction. Like that things are going to be evaluated using divergence and also directional derivative, right? So now solenoidal vector is another definition which is very important. Solenoidal vector. Solenoidal vector, when we say divergence of vector is going to be 0, then F bar is said to be solenoidal vector. Divergence of vector. Divergence is nothing but del dot of vector is 0, then F bar is said to be what? So solenoidal vector. Definition, they may ask for 2 marks. Define solenoidal vector. So then physically how will you say that? Del dot of F bar is the rate per unit volume diverging from the source. So del dot F bar that I said in the applications. Okay, how far it is moving from the source. The rate of flow, the rate of moving away is evaluated using divergence of vector. Let us discuss the problems. Find divergence of F bar where F bar equals to gradient of this. Okay, means F bar is what given? F bar equals to gradient, means del of x cube plus y cube plus z cube plus 3xyz. So del means here I bar into dou by dou x of plus j bar into dou by dou y of plus k bar into dou by dou z of x cube plus y cube plus z cube plus 3xyz. Okay, del means this differential operation on the function. So which is equals to I bar, del dot have to write now. Oh, wait. Okay, I bar dou by dou x means I am evaluating only F bar vector. F bar vector is not provided fully. Partially he provided in the information of gradient of a scalar point function is a F bar. So that gradient I am evaluating here. So I bar into dou by dou x of this is 3x square, and these two differentiations are going to be 0, and x differentiation 1 plus 3yz plus j bar dou by dou y of this 3y square plus 3xz plus k bar into dou by dou z of this 3z square plus 3xy. This is F bar. Now we got vector point function. Okay, so for this vector function he is asking divergence of F bar. So here divergence of F bar. Divergence of F bar means del dot F bar. Del dot F bar, what I gave here, dou F1 by dou x plus dou F2 by dou y plus dou F3 by dou z. This is the formula for del dot F bar. What is F1, F2, F3? F1, F2, F3 are F1, F2, F3 are I bar coefficients, and F2 is J bar coefficient, and F3 is K bar. Along I bar we have one function, that is F1. Along J bar we have another function F2. Along K bar we have another function F3. Now whose differentiation you have to write? Dou by dou x of F1. F1 is what? 3x square plus 3yz plus dou by dou y of F2. F2 means 3y square plus 3xz plus dou by dou z of 3z square plus 3xy. Okay, so now you differentiate with respect to x. What do you get? 6x is equal to 6x only. Dou by dou y of this is going to be 6y, because here we don't have any z term, and this is also we don't have x term, and even here also we don't have z term. So similarly 6z, so which is equals to 6 into x plus y plus z. This is divergence of f bar. So divergence of f bar is a scalar point function, no, which is not a vector point function, which is free of vectors. It's a scalar point function. So likewise. Next to find divergence of R bar, where R bar is provided by xi bar plus yj bar plus zk bar. So R bar equals to xi bar plus yj bar plus zk bar. So this will be taken as f1, f2, f3. Along I bar we have x1, along y bar y we have, along z bar, along k bar we have z. So those are all f1, f2, f3. So del divergence of f bar, divergence of R bar is equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where f1, f2, f3 are x, y and z. So therefore whose differentiations are going to be 1 and sum is going to be 3. 1 plus 1 plus 1 is going to be 3. This is very short answer style, but asking frequently. Okay, next find divergence of f bar, where f bar equals to r power n into r bar, and find n if it is solenoidal. First let us try to find divergence of f bar, then we see how when it is going to be solenoidal. For what value of n it is going to be solenoidal, that we see in the next part. First try to evaluate divergence of f bar. F bar means r power n into r bar. So let us introduce what is r bar. R bar is a position vector. R bar is a position vector that is defined by xi bar plus yj bar plus zk bar. This is position vector by default you have to take in vector field, and whose modulus R bar is going to be x square plus y square plus z square under root. This modulus of R bar used to be represented by R. So from this R square equals to, what do you get? X square plus y square plus z square. This information you required for proving this. Now you differentiate R square with respect to x, with respect to y, with respect to z. And what happens? Let us see. Differentiation of R square with respect to x, 2r dou r by dou x is equals to 2x only, because I am doing differentiation with respect to x. So R square differentiation is 2r, dou r by dou x is equals to 2x, x differentiation 1. So from this, what you can write? Dou r by dou x equals to, take 2r that side, 2x by 2r is left by x by r. Similarly, dou r by dou y by r you will get, dou r by dou z, dou r by dou z, dou r by dou z. dou r by dou z is going to be get as z by r. So these information you need to provide for f bar equals to r power n into r bar. Okay. So this information, if you provide this information, you will get 1 mark for proving that. Now I am going to f bar. F bar equals to r power n into r bar. Now I have to find divergence of f bar. So here first you expand it. R power n into r bar is xi bar plus yj bar plus zk bar. Okay. So when I multiply by x into r power n into I bar plus y into r power n into j bar plus z into r power n into k bar. So this is f bar. So we write this as f1. We assume this as f1, f2 and f3. Along I bar we have f1 that is by x into r power n. Along j bar we have f2 by y into r power n. Along k bar we have f3 by z into r power n. Okay. Now divergence of f bar. Divergence of f bar. So divergence of f bar equals to dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Okay. So which is equals to dou f1 by dou x. F1 is what here? Dou by dou x of x into r power n plus dou by dou y of y into r power n plus dou by dou z of z into r power n. Okay. So now with respect to x, UV rule you need to apply here because r is a function in terms of x and y and x, y and z. So both are functions of x. So you differentiate under UV rule. X differentiation 1 into r power n. Okay. U differentiation I wrote. I am writing r power v as it is. Now you write u as it is and r power n differentiation is n into r power n minus 1 into r differentiation is dou r by dou x. Okay. Similarly, even here also 1 into r power n plus y into n into r power n minus 1 dou r by dou y plus 1 into r power n plus n into r power n minus 1 into dou r by dou z. Instead of writing this expansion, you can simply write in a single term under summation, even that also you can, but anyhow I have proceeded now. Let us have like this. So now 1 into r power n is r power n, 1 into r power n is r power n. How many r power n's we have? 3 times r power n. So 3 into r power n plus here we have n into r power n minus 1, n into r power n minus 1, n into r power n minus 1 as common. So that I am taking n into r power n minus 1. So if I take n into r power n common, x into dou r by dou x is left. So x into dou r by dou x is x by r that I proved, that I said in the previous, dou r by dou x is x by r plus y into dou r by dou y. So y into y by r. So y I am writing as is dou r by dou y means y by r plus here z is there na. Here I forgot to write z. So z into dou r by dou z means z by r. So which is equals to 3 into r power n plus n into r power n minus 1 into x square plus y square plus z square by r na, on whole, into x square plus y square plus z square whole divided by r, as r is the common denominator in all the terms. right? So then which is equals to 3 into r power n plus n into r power n minus 1 x square plus y square plus z square is equals to r square I provided in the initial part. So we write this as r square by r, which is equals to 3 into r power n plus n into r power n minus 1 into r. R square by r is r. So which is equals to 3 into r power n plus n into r power n minus 1 into r is going to be r power n. So which is equals to n plus 3 or 3 plus n into r power n, which is equals to n plus 3 into r power n. This is divergence of f bar. Sorry, divergence of f bar. Okay, divergence of f bar I evaluated. And next part is when it is going to be solenoidal. Solenoidal is if f bar is solenoidal, if f bar is solenoidal, then divergence of f bar equals to 0 now. Divergence of f bar is equal to 0. Divergence of f bar, how much we got? N plus 3 into r power n. So n plus 3 into r power n is equal to 0. R power n never becomes 0 because r is a radius whose power is going to be some measure, will not be 0. So definitely n plus 3 is equal to 0 since r power n not equal to 0. So from this n is equals to minus 3. So for what value of n that f bar is solenoidal means for n is equal to minus 3 the function is going to be solenoidal. Next, evaluate del dot r bar by r cube where r bar equals to xi bar plus yj bar plus zk bar and r equals to r bar. Means for this question also you have to provide all this information. The same information you need to write. The same. This total information you have to take for solving this. So r bar equals to xi bar plus yj bar plus zk bar, and provided r equals to modulus of r bar, that implies r square equals to x square plus y square plus z square, and from this you can get dou r by dou x equals to x by r and dou r by dou y equals to y by r and dou r by dou z equals to z by r. Okay, now I am going to take this del dot. So this is the information I am going to apply in evaluation of del dot r bar by r cube. Del dot r bar by r cube is nothing but divergent of r bar by r cube. Okay, so del dot r bar by r cube now I am taking. So which is equals to del dot xi bar plus yj bar plus zk bar by r cube. Okay, so which is equals to del dot x by r cube into I bar, y by r cube into j bar, z by r cube into k bar. Okay, here I write this as f1, this I am taking as f2, this I am taking as f3. Okay, so you take f1, f2 and f3, you assume. So del dot is nothing but divergence. So therefore which is equals to dou f1 by dou x means x by r cube plus dou by dou y of f2 means y by r cube plus dou by dou z of z by r cube. So which is equals to dou by dou x of x into r power minus 3 I used to write. So this I will put under summation. Instead of writing the whole, I will put in simple summation, which is summation. If I take out the summation, this full expansion will come out. So instead of writing this whole expansion, I put just in summation part, so that the summation part inscribed all the expansion, right? So which is equals to summation dou by dou x of x into r power minus 3, where r is a function of x, y and z. You need to differentiate x and r also under UV rule. So then x differentiation 1, r power minus 3 you write as it is, and you write x as it is, r power minus 3 differentiation is minus 3 into r power minus 4. R power minus 3 minus 1 is minus 4 into dou r by dou x. Okay. So then summation equals to summation 1 into r power minus 3 is r power minus 3. So minus 3x because here plus here x into minus 3 is minus 3x. Minus 3x r power minus 4 into x by r, where dou r by dou x is, what I said, x by r, na? So that I am going to substitute. So r power minus 4 into x by r. Okay. So which is equals to summation r power minus 3 minus 3x r power minus 4 x by r. So x into x is x square. R power minus 4 by minus 4 by r is going to be r power minus 5. Is going to be r power minus 5. R power minus 4 by r is going to be r power minus 5. Okay. So this is what we are getting, r power minus 3 minus 3x square r power minus 5. So now you expand it. So if I expand it, r power minus 3 will be repeated 3 times. So it becomes 3 into r power minus 3 minus r power minus 5 will be common into, and 3 also is common, will be minus 3 also is common. So x square plus y square plus z square will come. When I expand the summation, these terms will be included. Minus 3 x square r power minus 5, minus 3 y square r power minus 5, minus 3 z square r power minus 5 will come when I expand it over the summation. Okay. So which is equals to 3 into r power minus 3 minus 3 into r power minus 5, where x square minus y square plus x square plus y square plus z square is r square. So which is equals to 3 into r power minus 3 minus 3 into r power minus 3. R power minus 5 into r power minus 2 is going to be r power minus 5 plus 2 is r power minus 3, which is equals to 0. Okay. Means del dot of r bar by r cube is going to be 0. That is del dot of r bar by r cube is 0. So from this we can say r bar by r cube is solenoidal. Of course, he has not mentioned that, but I am writing here. If you want, you can write, otherwise leave it. R bar by r cube is 0, whose dot product, whose divergent is 0 now. So it is solenoidal, we can say. So like this you can do the problem. Next, if f bar equals to if f bar equals to y into ax square plus z into I bar plus x into x square minus z square into j bar plus 2xy into z minus xy into k bar is solenoidal, then find A. What is A? They are asking. So here f bar is solenoidal. Given that f bar is for solenoidal, that implies divergence of f bar is 0. That implies dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is equal to 0. f1 here, this is, we assume this as f1, f2, f3. So that implies dou by dou x of f1. f1 means ax square y plus zy plus dou by dou y of x into x square x cube minus xz square plus dou by dou z of 2xy into z is 2xyz minus 2x square y square. This is. Now you differentiate. Okay. Yeah, to write is equal to 0. I have to write. Now that implies dou by dou x of this is 2ay plus dou by dou y of this is going to be 0, which is independent of y term, going to be 0 na, 0 plus dou by dou z of here. Dou by dou z means 2xyz differentiation is 2xy, and this is independent of z term whose differentiation is 0, is equal to 0. From this, here you will get 2axy, sorry, here 2axy. From this, 2axy is equals to 2xy. From this, a is equals to what? Minus 1. A equals to minus 1. 2axy equals to minus 2xy. When I bring plus 2xy that side, minus 2xy. So a is equal to minus 1. So this is how we evaluated a value by using solenoidal property. Next, show that this is solenoidal. Means here, if I take this as f bar, so here f bar equals to x plus 3y into I bar plus let y minus 3z into j bar x minus 2z into k bar. So solenoidal, if you want to prove that solenoidal, you have to take f bar, divergence f bar. So that equals to dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. So here f1 is, this is I am taking as f1, f2, f3. So that you substitute here, which is equals to dou by dou x of f1 is x plus 3y plus dou by dou y of f2 means y minus 3z plus dou by dou z of f3 means x minus 2z. So which is equals to with respect to x means 1, with respect to y means we will get 1, with respect to z means we will going to be minus 2, which is equal to 0. So that is divergence of f bar is equals to 0 implies f bar is solenoidal. Okay. Next, curl of a vector. Next operation. This is also vector operation. Curl of a vector is a curl of a vector field is again a vector field. Curl of a vector field is again a vector field. The curl of a vector field is obtained by taking vector product of the vector operator on a vector field. Means this is a differential operator, vector differential operator. I am taking cross product, means vector product. Vector product I have taken to the vector field. So here del cross f bar of x comma y comma z. So here what is f bar of x bar here? Here f bar of x of y comma z is taken as f1 I bar plus f2 j bar plus f3 k bar. Okay, if I take f bar equals to f1 I bar plus f2 j bar plus f3 k bar, then del cross of that is going to be take like this. Determinant of del cross f bar of x of y z is equal to determinant of I bar j bar k bar dou by dou x dou by dou y dou by dou z and f1 f2 f3, where f1 f2 f3 are coefficients of I bar component, j bar component and k bar component respectively. So this is curl. To evaluate curl of a vector, this is the formula you have to take. Determinant formula. You are all aware of how to find the determinant, so that you need to apply here. Okay. Now this is curl of a vector. Even a definition of curl of a vector is definitely asking on short answers type. Okay. So physical interpretation of curl. So omega bar is the angular velocity of a rigid body that will be half of the vector, means velocity of vector, and where v bar is the velocity vector, velocity of a point. Okay, angular velocity is equal to half of a velocity vector. So this is physical interpretation of a curl. Next, irrotational motion and irrotational vector. Any motion in which the curl of the velocity vector is null vector, that is curl of f bar is equal to 0 bar, is said to be irrotational motion. Okay, any motion in which the curl of the velocity vector is null, then that motion is said to be irrotational motion, otherwise it is said to be rational motion. Okay, and here f bar is said to be irrotational vector. And if f bar is a irrotational vector, then there exists a scalar point function. See, here if f bar equals to 0, means del cross f bar equals to 0, del cross f bar is equal to 0, then f bar can be written as in terms of del phi. Then there exists a scalar point function phi such that f bar can be written as del phi. So here phi is called scalar potential, this phi is called scalar potential, and f bar is called conservative vector field. So this what is conservative vector field definition they may ask, and what is differential scalar potential may ask definitions. These are the points. What is irrotational vector, what is irrotational motion, so they may ask for the short answers type. You please be aware of this, right? So when curl f bar is equal to 0, that the motion comes under irrotational motion, otherwise it is rational motion. Okay, and in such case f bar is said to be irrotational vector. If f bar is a irrotational vector, then there exists a scalar potential, there exists a scalar point function phi such that f bar is equals to del phi, then phi is said to be scalar potential. And if f bar is a irrotational vector, then f bar is said to be conservative vector field, right? Next, these are the applications of a curl of a vector. See, so how the water flows in a rotational motion, and this is in hurricane or in storms, in floods time, how the situation in a weather forecasting system it shows. Okay, means here how the applications of curl of a vector means. So when storms happen, so in case of storms, I'm just means in case of hurricane, in case of hurricane outbreak means very heavy storms happen. So there, here that rotational part exists in a red color. In red color, rotational part exists. Is we are able to see here na, the picture, rotational part, where curl is maximum. Curl is heavily exists. Curl value is very heavily exists there. Okay, curl is going to be high. A lot of curl is going to be happen. So when the curl is lot, there the rotational motion is very highly exists. Okay, in the blue shaded part, curl is very little. Curl is very little. So the application of curl is used on finding where the hurricane breaks out, where in which places that is affected, where the storms are mostly occurring, means means when the depression happened, no, in the depression happens where that is means affected by hurricanes, which place is affected by hurricanes, that will be evaluated using curl in the weather forecasting system. Okay, so in the heavy floods, you will get a huge amount of flow of water. It reaches to canals, rivers and dams. After dams it reaches. So when the heavy flow of water reaches to dams, that dam has to sustain the flow of water, means opposite the flow of water, otherwise the sustainability of the dam will goes down. So to sustain the dam protection means the dam should be dam should be constructed in such a way that to protect the heavy flow of water in the floods. These rotational flow means this rotational flow has to develop in the dam. That in such a way the construction of the dam should be. When the rotational flow is happen in case of a heavy flow, then the flow of water will not damage the walls of the dam and gates. So in that sense, the technology is used for protection of dams, walls of the dams and gates. Okay, so likewise the curl of applications are there in weather forecasting and in the construction of dams and gates also. If a heavy flow of water will come, means gates and dams of walls will get damaged. So that will be reduced by rotation of the flow, means the flow of water in rotationally, if you construct in such a way, then the heavy flow will reduce the flow speed of this flow of water. So then we can avoid we can reduce the means damages of the dam and its gates. Okay, that is what one application we have. It's a very excellent application we have under curl. Okay, so now let us see one problem under curl, where f bar equals to x plus 3y I bar plus y minus 3z I j bar plus x minus 3z k bar. So here f bar equals to this, so curl f bar equals to del cross f bar, which is I said the formula I bar j bar k bar dou by dou x dou by dou y dou by dou z. Okay, so under dou by dou x, x plus 3y, y minus 3z and x minus 2z, because here f1, f2, f3, this is f1, you treat f2 and f3. So these are all f1, f2, f3. Now you evaluate the dou by dou y of this 0, because no term is with which is independent of x y term, which is independent of y term. Dou by dou y of this 0 minus dou by dou z of y minus 3z is minus 3 minus j bar into, okay, so dou by dou x of this is 1 minus dou by dou z of this 0, as this is a independent of z term whose differentiation is 0, plus k bar into dou by dou x of this is 0, since it is a independent of x term, dou by dou y of x plus 3y is minus 3. So which is equals to 3i bar minus j bar minus 3k bar. So this is curl F bar. Okay. So one problem I have discussed on curl F bar. The remaining part, I have to discuss some more problems on curl F bar. Onwards, after completion of curl F bar, we will go for, we will discuss on vector identities. So in the next session, we will see the remaining part of vector differential.